Greetings, and here we have another edition of our Solving Trig Equations series, part 3. We have notes number 49, and what's different this time is we're not solving the equations for answers between 0 and 2 pi radians. We are solving the equations for all answers. That means these equations will have infinitely many answers. So if you thought that some of my previous lessons were long and felt like they never ended, well, guess what? This one can literally never end because we have infinitely many answers to find. So let's get to it. Number 1. So this looks like an equation that you have solved before. In fact, you have solved this exact same equation before, but you solved it for a finite list of answers, and now we're going to solve it for all answers. So we start out the same way. We're going to divide both sides by 2. So we have sine theta equals square root 3 over 2. And then we're going to take the inverse sine of both sides. So we have theta equals inverse sine of square root 3 over 2. And now we think about this. Okay, so square root 3 over 2 is positive. So that means for sine to be positive, we're in quadrant 1 or we're in quadrant 2. And we know the opposite would be square root 3 and the hypotenuse would be 2. So we figure out that we have a 60-degree angle, 60-degree reference angle. And so one answer is 60 degrees and the other answer is 120 degrees. We'll convert it to radians in a minute. So we have theta is 60 degrees or theta is 120 degrees. Now, how do we get all the rest of the answers? Well, remember that there are infinitely many angles that are coterminal with 60 degrees. So if your terminal side is right here, and you go all the way around the circle again, you get to the same terminal side. That would be adding 360 degrees. Or you could do it again and add another 360, add another 360, infinitely many times. Or instead of going counterclockwise, you could go clockwise and you could subtract 360 degrees. So what we're going to do is say that the infinitely many answers that correspond to this first answer are 60 degrees plus 360 degrees times n, where n is any integer. So that means n is 1, n is 2, n is 3, n is 4, n is 0, n is -1, etc. So that represents all the times around the circle again. The same is true for the other answer. We're going to add 360 degrees times n to it, and that accounts for all of those answers. So sorry, but this is actually not going to be an infinitely long lesson because we have found a way to consolidate our answers. Now we're supposed to answer in radians, so let's go ahead and just convert those to radians. So we have 60 degrees is pi over 3, and then 360 degrees is 2 pi. So we would have pi over 3 plus 2 pi n, and we would have 120 would be 2 pi over 3 plus 2 pi n. And that is infinitely many answers plus infinitely many answers. Does that mean it's 2 times infinitely many answers? I guess so, but it's still infinitely many answers. So there's number 1. We're going to do 4 examples. Number 2. You've also solved this kind of equation before. It's already factored for you, so you're going to set each factor equal to 0. Tangent x minus 1 equals 0. Give myself a little space here. Cosine x plus 1 equals 0. We're going to solve each of these for x. Going back to the first one, add 1 to both sides. Tangent x equals 1. Take the inverse tangent of both sides. X equals inverse tangent of 1. Think about where that is. It's positive, and tangent is positive in quadrant 1 and quadrant 3. So we have a 45-degree angle, 45-degree reference angle. So we have 45, and then the other one is 225. So then answering first in degrees, because that's what we're comfortable thinking in. I am at least comfortable thinking in degrees. So we have 45 degrees, and we have 225 degrees. Now, to represent the infinitely many answers coterminal with those, just like in number 1, we're going to add 360n to both. But wait, there's more. Notice that for this particular scenario, these two angles are half a circle apart. So once you have one of them, the 45 degrees, you could just add half a circle to get to another answer, add half a circle, get to another answer, add half a circle, get to another answer. And what is half a circle in radians? Well, let's start with degrees. What is half a circle in degrees? That's right, it's 180 degrees. So we could actually consolidate these answers together, and we could just take one of the answers, 45 degrees, and then we could say plus 180 times n, and the 180 is going to take you to the next answer, and the 180 again is going to take you to the next answer, and so on and so on and so on. So that's a more efficient way to write the answer. And in radians, that would be pi over 4 for 45 degrees plus pi for 180 degrees times n. So that's part of our answer, but don't forget we still have the other half. So if cosine x plus 1 equals 0, subtract 1 from both sides, take the inverse cosine. The angle whose cosine is -1 would be 180 degrees. Unit circle, quadrantal angle. So x is 180. That's the only one there is when you go around the circle one time. But then all the rest of them, coterminal with that, would be 360 degrees or some multiple of 360 degrees away. So we still add our 360n and then convert that into radians. So we have pi plus 2 pi n. Oakley dokley. Let's take a look at number 3. Okay, so what we notice in this equation is that both terms have a factor of sine theta. So let's start by factoring it out. We have sine theta, oops, try that again, sine theta times the quantity tangent squared theta minus 1. Now we're going to set each factor equal to 0 and solve each one. Sine theta equals 0, or tangent squared theta minus 1 equals 0. Okay, going back to the first equation, we'll take the inverse sine of both sides. The angle whose sine is 0, we have a couple of them. We have 0 degrees, oops, and we have 180 degrees. So theta could be 0 plus 360n, or theta could be 180 plus 360n. But just like a previous problem, since these are half a circle apart, you don't have to list it like this. You can just start with one answer and then add 180 degrees to get to the next answer, add 180 degrees to get to the next answer, and so on and so on. So we're going to consolidate this into just 0 plus 180 n. But you know what? You don't write 0 plus something, you just eliminate the 0. So the answers would be 180 n. And then in radians, that would be equivalent to pi times n. Back to the second part of the problem. Tangent squared theta minus 1 equals 0. Add 1 to both sides. Square root both sides, and don't forget the plus or minus when you square root. So then we're going to have tangent theta equals 1, so theta equals inverse tangent 1. And also theta equals inverse tangent -1. Okay, the angles whose tangent is 1 would be the 45, and then across from it the 135. And the angles with a tangent of -1 would be the 135 and the 315. All the quadrants are covered there. So we have 45 plus 360n. We have 135 plus 360n, but are you anticipating how we're going to consolidate this? We have 4 answers that are all how far apart to get from one to the next. They're all equidistant. They're all 90 degrees apart. So we can consolidate this into 45 degrees plus 90 degrees times n. And then in radians, we have 45 is pi over 4 plus, and then 90 is pi over 2. So pi over 4 plus pi over 2 times n would be the radian description of those answers, and we have the other answers from the first part of the problem. Okay, we're making good time here. We have one more example to go. Number 4. So this one is a quadratic in disguise. Let's get everything over to one side and then see if we can factor it, and if not, we'll use the quadratic formula. Let's see here, let's try 2 cosine x and cosine x. Let's try 1 and 1, and plus the first one minus the second one, and that'll do it. So good, that's factorable. That makes me happy. Set each factor equal to 0. And then let's solve the first one. So we get 2 cosine x equals -1. So cosine x equals -1/2. So we take the inverse cosine, and then we think about which quadrants we're in. If cosine is negative, we're in quadrants 2 and 3. We would have 1 as the adjacent and 2 as the hypotenuse. So that means our reference angle is 60. So that means our answers are 120 and 240. So x is 120 plus 360n, or 240 plus 360n. These are not half a circle apart, and so we're not going to be able to consolidate these two answers. We're just going to leave them separated, and then we'll also change them to radians. So we have 2 pi over 3 plus 2 pi n, and we'll have 4 pi over 3 plus 2 pi n. Okay, got those answers, and now let's finish with the other half of the problem. Add 1 to both sides, take the inverse cosine, and then let's see the angle whose cosine is 1. Boy, all this talk about angles, it reminds me of a joke. And this joke is dedicated to Aidan Soule and Matthew Grigsby. What do you call an angle that got into a car crash? A rectangle. Okay, so the angle whose cosine is 1 would be 0. So we have 0 degrees plus 360n. Again, we don't need to write 0 plus something. Let's just write 360n. And then convert that into radians, and we have 2 pi n. So there you have it. Trig equations with infinitely many answers. Homework. Solving trig equations worksheet 3. Check answers, ask questions, send pictures. Thanks everybody. You girls and guys are doing a great job.